Hey students, family members, this is Mr. Panza. Thanks for joining us for tonight's homework help video. Tonight we're going to be focused on geometry because we have a geometry test coming up tomorrow. Make sure that you're checking all your answers. Maybe try and go through it once yourself, or if you don't feel that confident, go ahead, take a look at the answers that I'm providing for you to the main question here. How do we solve geometry problems? And this is the review sheet. And make sure that after you have reviewed how I completed the problems that you actually go back and complete the problems yourself. Practice makes perfect. The first thing I'm going to tell you, there are a couple of errors on this homework sheet, so watching this video is going to help you. The first error is the fact that there is no dotted line on this second figure. Well, now that there is, we can answer this question. We need to tell whether the dotted line on each shape represents a line of symmetry. Well, I know that symmetry is when you split a figure in half with a dotted line, an imaginary line, and the figure is identical on both sides. It looks exactly the same. So for example, if I had a circle, let me just grab a circle here for you. Not the best drawer, so actually using my tools here will help. If I had a circle and I draw a line right down the middle, I'm going to have two half circles. This side looks identical or exactly alike to this side, which means this circle has at least one line of symmetry. A circle has tons of lines of symmetry, but at the same time, just recognize that as long as it looks exactly the same, you have symmetry. So look at the dotted lines. Does this trapezoid have symmetry? Well, a trapezoid does have symmetry, but only if you split it this way. And because the dotted line is going that way, this trapezoid does not have a line of symmetry. This one clearly does not have a line of symmetry because the dotted line is in the wrong spot again. If you had it this way, you would have a line of symmetry. So that one is no. This one, because it's split where it is, does have a line of symmetry. So out of these three shapes, our second shape is the one that has a line of symmetry. A polygon is a shape that has at least three sides. Here are three examples of polygons that you see on your review sheet tonight. A pentagon, which has 5 sides, and I would label these because that's going to be helpful for the upcoming question. The hexagon has 6 sides. The way we remember that it's a hexagon is there is an X there, just like in the word 6. I help the students remember pentagon because it's shaped like the Pentagon in Washington, but also this looks like a home plate in baseball, and the home plate, that P in plate, reminds me P in pentagon. Finally, our shape at the bottom is a trapezoid, which has 1, 2, 3, 4 sides. The property of a trapezoid is you have one pair of parallel sides. That would be this top line is parallel to the bottom line. Even though it's not the same length, parallel means that they will never touch and they will stay equally distant from each other. The bottom question after you name these polygons is how many more sides does shape 1 have than shape 2? Well, that wasn't supposed to be the question. As you can see, that's mistake number 2 on tonight's homework, because shape 1 has 5 and shape 2 has 6, so technically shape 1 does not have more sides. However, if you reverse it, what you would have to do would be take shape 2, subtract shape 1, and figure out that this hexagon has one more side than that pentagon. Flip to page 2. Take a look at this triangle. What type of triangle is it? Well, we taught the students that perpendicular means that a line or a line segment going straight up and down, and a line or line segment that runs immediately underneath it like this, that forms a square angle. You'll normally see one of those square angle signs. A square angle is nothing more than a fancy term for a 90-degree angle. We call that a right angle. So just keep in mind that because there is a right angle in this triangle, we call this a right triangle. Whenever you see that perfect square, you're talking about right triangles or right angles. Because we're talking about geometry, we are also measuring and drawing angles. Tonight, I sent home a protractor with your student. Make sure they don't forget it tomorrow. I told them if they forget it, then they don't get to use a protractor. So let's take a look at these 4 questions here. I'm actually going to project it on my document camera here at school. Here's my document camera. Let me make it a little bit bigger so you can actually see it. Sorry for the blurriness. Just give it a second. Let me raise this up a little so you can actually see it. Okay. Here's the first thing I need to do. I have an angle here. And I need to take my protractor and know enough about the protractor that this little open circle, which actually isn't open, but that circle needs to hit this vertex right here. A vertex is where two lines or line segments meet to make a point or an angle. So I take that circle and I line it up. Now, I could line it up and make my protractor look like this, but that's where the second part comes into play. This line right here must run perpendicular on the bottom, so you have to match this line on the bottom to the line that is going across in your angle. And once you have it perfectly lined up, just take a look at where the angle is pointing. Now I'm hoping that the students who maybe went through this problem first didn't just write down that it was 50 degrees. Because what some students were struggling with was looking at this and immediately saying, oh, 130 is the degree marker. Well, not really, and here's why. Because this is an acute angle. So the first thing the student should have done was written the word acute down, which means it's less than 90 degrees. So now when I look at this problem and I use my protractor, I've got a choice to make. I know that this angle either measures 50 degrees or 130 degrees. And I can tell with 100% certainty that it is 50 degrees. Why? Because it's a cute little angle. The exact opposite for this one over here. This is not an acute angle. It is an obtuse angle. And an obtuse angle is actually greater than 90 degrees. So anything over and above a right angle is an obtuse angle. So again, take this little point here, match it up with my vertex at H, make sure that that line is well adjusted on the bottom, and then take a look. Where does that arrow point? We told the students we'd be somewhat lenient within 5 degrees, so anything between this mark and this mark is going to be considered correct. Well, here I have 170 degrees, and here I have 160 degrees. How do I know it's 170 or 160 or between there? Because 10 and 20, that would be acute. But 170 and 160, that's obtuse. And when I look a little bit closer, I see 160. This middle mark would be 165. It's probably somewhere between there. So I'm going to say it's 165 degrees. Very similar for drawing angles. Drawing angles, you have to first tell me what this angle is. It's 15 degrees. So, because it's 15 degrees, I'm still trying to get some of that blurriness out of there, and I apologize for that. Because it's 15 degrees, this is going to be an acute angle. So the first thing I need to do, take my handy-dandy protractor. I'm going to fade it over here, draw a dot where the dot would be, and then draw my bottom line. Don't move the protractor, because you need to find where 15 degrees is and make a mark. Here's 10 degrees, there's 20 degrees, which means 15 has to be right there in the middle. I put a dot. Now, I need to connect the dots. I've got a dot down here, which is going to be my vertex, and a dot up there, and I just draw it. Does this make logical sense? Absolutely it does, because this angle is certainly going to measure less than 90 degrees. It's an acute angle, and it looks about 15 degrees. You would do the same exact thing for 145 degrees. I start with a dot. I'm actually going to start it over here. Draw my line. Look for 145, which is right here. Oh, I'm sorry, that's 135, because 130, 140, 150, this would be 145. And then connect my dot to my vertex. I have a 145 degree angle measure. All right, let's flip it over. Here we go. Next page. Now I have actual protractors on the page for you. And what I want the students to be able to tell me is what it actually measures. So the first thing they need to do is tell me, is it an acute or an obtuse angle? This is acute because it's clearly less than 90 degrees. You can also have the students possibly highlight or make sure that they see exactly where the line is. So here's the line, and the angle goes up here, and it is between those two numbers, between 120 and 130. If it's between it, we're talking 125, but in this case it's not, because remember, I look over here, it's acute less than 90. It can't be 125. It has to be what's in between these, which in this case is 55. This one is obtuse. It's greater than 90 when I highlight my points. So that's 55 degrees because it's an acute angle. So the obtuse angle is greater than 90. I take my highlighter. This is obviously obtuse because it's bigger than 90 degrees. I've written down that it's obtuse. I take a look at where that measurement is, and I get 105 degrees. The students also need to be able to recognize where angles are on a shape. So every acute angle is what we're looking for on this shape here. Here are the angles. I want you to recognize that angles are not just points. A lot of the students immediately think, oh, well, right here is angle E. It could be called angle E, but in geometry, we would call this angle FEG. We could also call it angle GEF. And because it is less than 90 degrees, we're talking about an acute angle. I'd like you to go ahead and write down these angles and try and see if you can find them. Another question that you may find on your test, you may see or hear a question that says, I want you to find the point which is on line segment HI. So the students need to be able to realize that, well, HI line segment is right here. The point on that line is point X. Now we're just labeling. Acute, less than 90 degrees. Right angle, it's got that perfect square mark there, 90 degrees exactly. Obtuse, greater than 90 degrees. Acute, less than 90 degrees. Same thing for these bottom two. Obtuse because it's greater than 90, acute because it's less than 90. And you can have the students practice by drawing the actual angles, see if they are greater than or less than 90 degrees. What's 90 degrees? That perfect square that would land right there with a square mark. If it doesn't do that, it's either acute or obtuse. Flip it over one more time. Now we have to find the missing angle lengths. That can be somewhat difficult. You have to make sure that you're paying close attention to what you know and what you're trying to figure out. So we're trying to determine the value of angle A. In this case, angle A is here. And for number 2, angle A is the entire length. So let's figure it out for number 1 first. I know that this measurement right here is 58 degrees. I also know that the entire measurement is 88 degrees. Even though it looks like a right angle, it doesn't have the perfect square, which means it's 88 degrees. So how can I figure out what this little measurement is? What I have to do is take 88 and subtract 58 to get the small angle. 8 minus 8 is 0. 8 minus 5 is 3, which means this angle is equal to 30 degrees. What happens if the students choose the wrong operation? Don't panic. If they add instead, they should know that it can't be a huge angle if they added 88 and 58 because this is close to 90 degrees. So this little bit is so small it's an acute angle. Same difference here, except you're doing something different. I need to find the full length of A. Well, I'm given this angle measure and this angle measure. In this case, I don't subtract, but I add. 125 plus 36. 5 plus 6 is 11. 3 plus 3 is 6. And 1. So angle A is 161 degrees. Almost done. Draw a line segment JU perpendicular to KL. Perpendicular is 90 degrees. So you can either go on this side or this side and make line segment JU. As long as you have a 90-degree angle. And finally, draw a line segment EO parallel to RW. Well, parallel, they never touch. It would be right on the graph. It's a line segment EO. I hope this helped you answer geometry problems. We'll go over it again tomorrow before the quiz, so make sure you go back and study it tonight. Thanks for checking it out.